This is a practice paper for the 2022 GCSE exam, Edexcel, higher tier, paper 1, that's a non-calculated paper. All the questions in this exam are based on the advanced information provided by the exam board. So the topics in this paper are the same as the topics that will be in the paper 1 exam this summer. So here's the formula sheet that we're given. This will be given to you in the exam. Some of this may be useful in this paper. We can always return to it if we want to. Question 1. Write 240 as a product of its prime factors. So product means multiplied. So write 240 as prime numbers multiplied together. So let's break 240 down. So break 240 down. So it's 2 times 120. And 2 is prime. 120 can be broken down again. So let's call that 2 times 60. 60 is 2 times 30. 30 is 2 15s. And 15 is 3 times 5. We could have done this a different way. If we started with 240 and said it's 10 times 24. Neither of those are prime. So we would have changed 10 into 2 times 5. 24, we could have said, is 2 12s. 12 is 2 6s. And 6 is 2 times 3. We end up with the same numbers at the bottom of the tree. We've got 2 times 2 times 2 times 2 times 3 times 5. So if we did 2 times 2 times 2 times 2 times 3 times 5, if we multiplied them all together, we would get 240. So that's our answer. Question 2, work out 3/4 minus 7/10. To add or subtract fractions, we need to make the denominators the same. So we can make them both 20 by multiplying the top and bottom of 3/4 by 5 and the top and bottom of 7/10 by 2. If we'd multiplied 3/4 top and bottom by 10 and multiplied the top and bottom of 7/10 by 4 and made the denominators 40, that would also be correct. We'll just have bigger numbers. So 3/4 multiplied top and bottom by 5. 5 3s are 15. 5 4s are 20. For 7/10, we're doubling the top and bottom. That's 14 20ths. Now we've got the denominators the same. We can take them away. 15 20ths. Take away 14 20ths is 1 20th. Part B, work out 2 1/3 times 3/5. Give your answer as a mixed number in its simplest form. So to multiply fractions, we need to change our mixed number into an improper fraction. So to do that, we've got 2 1/3. So we've got 2 whole numbers. 2 ones, 2 wholes, and 1/3. So how many thirds have we got? The 2 wholes give us 6 thirds, plus another third. That's 7 thirds. 2 times 3 is 6. So that's 6 thirds, plus the extra third, 7 thirds. Now we can multiply these together. Before we multiply, we can simplify. So if you divide top and bottom by the same thing, you can simplify it. So you can divide the top by 3 and the bottom by 3, and that simplifies this fraction. So now we've just got 7 times 1 on top, which is 7, and 1 times 5 on top, which is 5. So 7/5, but we need to give our answer as a mixed number. So we've got 5/5 makes 1 whole, and we've got 2 more. So 1 whole and 2/5. Question 3. In a bag there are only red counters, blue counters, green counters, and yellow counters. A counter is taken at random from the bag. The table shows the probabilities that the counter will be green or will be yellow. The probability it will be red is twice the probability it will be blue. So we can call these 2x and x. Probability of red is twice blue. There are 21 green counters in the bag. Work out the number of red counters in the bag. So we can work out the probability of red because we know all the probabilities have to add up to 1. So 2x and x make 3x. And we've got 0.35 and 0.2, which is 0.55. So 3x plus 0.55 have to make 1. So let's take 0.55 from both sides. So 3x is 0.45. Then divide both sides by 3. So 45 divided by 3 is 15. 0.45 divided by 3 is 0.15. So that's x, so that's blue. And double that is red, which is 0.3. So there are 21 green counters in the bag. So 21 green counters. So 0.35 times the number of counters in the bag is 21. So if we had a calculator, I'd probably divide both sides by 0.35. You could still do that, and that will tell you the total number of counters. Because we don't have a calculator, I think it might be easiest to say that 0.35 is 35%, so 35% of the number of counters is 21. We need to know what 30% is, what 0.3, how many red counters there are. So if we divide both sides by 7, we can say that 5% of the counters, I'm only dividing by 7 because it's a factor of 35. And 5% will be something we can work with. If I divided by 5 and got 7%, that wouldn't be as useful to me. So 5% of the number of counters is 21 over 7, which is 3. And I need 30%. So 30% I can get from 35%, take away 5%. I could also do 5% times 6, which will get me there, get me the same answer. So it's 21, take away 3, which is 18. If I'd done 3 times 6, I would have also got 18. So there are 18 red counters. Question 4. Here is the graph of y equals 2x plus 6 minus x squared. So we've got a negative quadratic graph drawn for us here. And the question says, part A, write down the turning point of the graph. So it's the same graph, it's got the same equation. So the turning point is where it turns, where it stops going up and starts going down. So that's this point up here. So what are the coordinates? That's 1, 7. Use the graph to find the roots of the equation. X squared equals 2x plus 6. If we take away x squared from both sides, that's 0 equals 2x plus 6, minus x squared. So it's the same graph as the one above. The roots, this is where y equals 0. So y has been made into 0. Y equals 0. That's where it crosses the x-axis. So it crosses here and here. They are the points where y equals 0. They are the roots of the graph. So we've got negative 1.6 and positive 3.6. So negative x equals negative 1.6 or x equals 3.6. Question 5. 2y is bigger than 5 and less than 12, where y is an integer. Write down all the possible values of y. So we've got 2y. It'd be easier if we halved it. So we'll half everything, half the whole inequality. So that gives us 2.5 is less than y, and y is less than 6. So it has to be an integer. That means a whole number, and it can't equal 6 because it hasn't got a or, it's not a less than or equal to sign. It's just a less than. So it's got to be bigger than 2.5. So it can be 3, it can be 4, or it can be 5. It can't be 6 because it's less than 6. Part B, solve. 4 is bigger than 19 minus 3x. I'm going to avoid timesing or dividing by a negative number when I solve this. So I'm going to plus 3x to both sides. So that will give me 4 plus 3x is bigger than 19. Then take away 4 from both sides. 19 take away 4 is 15. And then divide both sides by 3. So x is bigger than 5. If you did do it differently, if you did start by taking 19 away from both sides, you'd have to divide by a negative 3, which will flip the sign over. So if you had taken 19 away from both sides, you have negative 15 is bigger than negative 3x. And then divide both sides by negative 3. When you times or divide by a negative number, the sign flips over. So instead of bigger than, it becomes less than. So negative over a negative is a positive. 15 over 3 is 5. So 5 is less than x. So you get the same answer. X is bigger than 5. But it's easier if you avoid timesing or dividing by a negative number. Question 6. Dermot has 240 counters. The counters are either red or blue or yellow or green. 15% of the counters are red. So let's figure that out first. So 15% of 240 are red. To find 10%, I can divide by 10. So 240 over 10 is 24. That's 10%. Half of 10% is 5%. So 12 is 5%. So 15% must be 24 and 12, which is 36. So 36 red counters. 2/5 of the counters are blue. So 2/5 of 240. I can find 1/5 by dividing by 5. So 240 over 5 is the same as double top and bottom. 480 over 10, which is 48. So that's 1/5. 2/5 is, well, 2/48, which will be 96. So there are 96 blue counters. The ratio of yellow counters to green counters is 3:1. Work out the number of yellow counters. So we can find the total number of yellow and green, and then we'll share in the ratio. So the ratio of yellow to green is 3 to 1. So 3 boxes yellow to 1 box green. But we need to know the total first. So we've got 36 and 96. So 36 and 96. Add them up. So 6 and 6 make 12. 1 and 9 and 3 is 13. So 132 blue and red. So 240 take away that will give us the number of yellow and green. So 240 take away 132. That's going to be 108. So there's 108 yellow and green. So 108, and there are 4 boxes here. 3 to 1, that's 4 parts. So 108 divided by 4 is 54 over 2, which is 27. So each box has got 27 in it. There are 27 green, 3 times 27 yellow, 3 20s are 60, 3 7s are 21. That's 81. So there are 81 yellow counters. Question 7. Here's a cube, and each side of the cube is 0.05 centimeters long. Work out the volume of this cube. Give your answer in standard form. So the volume of a cube will be, well, the length cubed. 0.05 times 0.05 times 0.05. So we want 0.05 cubed. We need to give our answer in standard form, so it might be easiest if we do our working in standard form as well. So 0.05 in standard form. So standard form is a number between 1 and 10, which will be our 5, and then times 10 to a power. So to get from 5 to 0.05, we have to, we'll divide by 10 twice. So it's 5 times 10 to the power of negative 2. And then it's this cubed. So 5 times 10 to the power of negative 2 cubed. So 5 cubed, 5 times 5 times 5 is 125. And 10 to the power of negative 2 cubed. So just multiply these two numbers together. 10 to the power of negative 6. That isn't in standard form, because standard form has to be a number between 1 and 10. So we can change 125 into 1.25 times 10, 2 times 10 squared. So we just simplify by adding these indices to finish, or multiplying the indices to finish. So we've got 1.25 times 10 to the power of 2 plus negative 6, 2 take away 6, negative 4. Question 8. ABCDEF is a hexagon. Angle CDE, this one, is 2 times BCD. So if this one's x, this one is 2 times it, 2x. Work out the size of angle CDE. So that's our 2x. We need to work out what 2x is. We need to know the angles in a hexagon. So you could count how many triangles there are. So 1, 2, 3, 4 triangles. So 4 lots of 180. Or you could remember the formula. Number of sides take away 2 times 180. Either of those, so 4 180s. 2 times 180 is 360. Double that, 720 degrees. So in total, they have to add up to 720 degrees. We can add up the angles we've got so far. So 144, 129, 125, and 121. So add them up to see what we've got. So 1 plus 9 is 10, plus 5 plus 4 is 19. So 9 in the ones carry 1 over. 2 plus 2 plus 2 is 6, plus 4 is 10, plus the 1, 11. And 1 plus 1, or 5 ones, make 5. So 519 degrees so far. So 2x plus x plus our 519 has to equal 720. So let's take 519 away from both sides. So 2x plus x is 3x. 720 take away 519. So take away 500 will give us 220. Take away 19, 201. So divide both sides by 3. So how many 3's go into 201? None go into 2. 6 go into 20. That makes 18. So 2 left. And 7 3's go into 21. So x must be 67 degrees. But that's not what we're working out. We want 2x. So double the answer. Double 60 is 120. Double 7 is 14. So 120 and 14 is 134. Question 9. Liquid A has a density of 1.2 grams per centimeter cubed. We've got a density question. So density is mass over volume. So density, 150 centimeters cubed. Volume of liquid A is mixed with some of liquid B to make liquid C. So A and B are mixed to make C. Liquid C has a mass of 220 grams and a density of 1.1 grams per centimeter cubed. Work out the density of liquid B. So we've got information about A and C. So we can find out the missing bits of information for A and C, and then to find the information for B, we'll be doing C take away A. So we need to know the mass and volume for A, the mass and volume for B. And then we'll do, so the density of B will be the mass of, the mass of B will be the mass of C minus the mass of A, and the volume of B with the volume of C, take away the volume of A. So let's work out the missing information. So for A, we need the mass. So for A, mass is going to be density times volume. So 1.2 times 150. So if you divide 150 by 10 and times 1.2 by 10, we can change this into 12 times 15. Or we could think of this as adding 20% on to 150. Either way, so 10 15s are 150, plus 2 15s, that's 180. So 180 grams. And for C, for C, we've got mass and density. We need volume. So volume is, well, if we multiply both sides by volume, we get volume times density equals mass. Then to get volume by itself, divide both sides by density. So mass divided by density. So 220 divided by 1.1. If we multiply top and bottom by 10, 2,200 divided by 11. 2 11s going to 22. So it's 200 volume centimeters cubed. So now we can work out the density of B. So the density for B, so the mass is the mass of C, take away the mass of A. Mass of C is 220. Mass of A is 180. And volume of C was 200. Take away the volume of A, which was 150. So 220 take away 180 is 40. 200 take away 150 is 50. So we've got 4/5, or as a decimal, 0.8. So the density of B is 0.8 grams per centimeter cubed. Question 10. 10 students have a mean height of 150 centimeters. 4 of the students have a mean height of 165 centimeters. Work out the mean height of the other 6 students. So the mean is the sum, everything added together, divided by how many. In this question, we're being given the mean and how many, so we can use that information to find the sum, to find what they all add up to. So 10 students have a mean height of 150 centimeters. To find out what they add up to, it's the mean times how many. So for 10 students, I put 10s, the sum is 10 times 150, which is 1,500 centimeters. For the 4 students, the sum, them all added together, all their heights added together, is 4 times 165. So we can double it or double it again, or we can do a long multiplication. 4 5s are 20. 4 6s are 24. Add on the 2, 26. 4 1s are 4 plus the 2, 6. So 660. Work out the mean height of the other 6 students. So the total height of all the students is 1,500. The total height of 4 of the students is 660. So if we take them away, we'll find the total height of the other 6. So 1,500 take away 660. So take away 600 will get us to 900. Then take away 60, 840. So that's the 6 students, that's their total height. There are 6 of them, so the mean is 840 divided by 6. So 6 goes into 8 once, we have 2 to carry over. 6 goes into 24 4 times, so it's 140 centimeters. Question 11. The points A, B, C, and D lie in order on a straight line. So we've got the ratio of AB to BD is 2 to 5, and AC to CD is 4 to 7. So we've got a straight line with 4 points A, B, C, and D. A, B to B to D is 2 to 5. So 2 parts and 5 parts. AC to CD is 4 to 7. So A to C is 4 parts and C to D is 7 parts. So we need to make these comparable. And the only way we can do that is by making them add up to the same number. So at the moment, 4 plus 7 is 11. So 11 parts for 4 to 7. 2 to 5 is 2 and 5 make 7. So that's 7 parts. We need them to be the same. So let's multiply this one by 7 and this one by 11, and they'll both be out of 77. So I'm going to say AB to BD. It was 2 to 5. I'm multiplying it by 11. So it's 22 to 55. It's now out of 77. And AC to CD was 4 to 7. It had 11 parts. I'm going to multiply them by 7. 7 4s are 28. 7 7s are 49. So now that is also out of 77 parts. So if I redraw this, so A, B, C, D. So A to B is 22 parts and B to D is 55. A to C is 28 parts and C to D is 49. So how can we write the ratio? So with 77 parts, we know A, B, B, C, C, D. A to B is 22 parts. C to D is 49. So what's left in the middle? So 28 take away 22 is 6. Or 55 take away 49 is 6. So now we're out of 77 parts. We've got a ratio of 22 to 6 to 49. Question 12. John plays a game where he can win, draw, or lose. The probability John wins any game is 0.5. The probability he draws any game is 0.3. John plays 2 games. Work out the probability that John wins exactly 1 game. So we've got the probability he wins and the probability he draws. We don't have the probability he loses, but we can work it out because all the probabilities have to add up to 1. So 0.5 and 0.3 make 0.8. So there's 0.2 left to make a whole. So he's going to play 2 games. For this, we can draw a tree diagram. So if we draw a quick tree diagram, so we're going to have 3 branches for the first game, win, draw, or lose, and then 3 again for the second game. Again, he can win, draw, or lose. So we'll just draw that. So there is our tree diagram. So we can win, draw, or lose the first game, and win, draw, or lose the second game. So the probability he wins any game is 0.5. So the probability of winning the first game is 0.5. And no matter what happens in the first game, if he wins, draws, or loses, the probability of winning the second game will also be 0.5. The probability he draws any of the games is 0.3. And the probability that he loses any of the games is 0.2. So this is everything that can happen. We can win, 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 draw, win, lose, draw, win, draw, 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 lose, lose, win, lose, draw, or lose, lose. And we want the probability he wins exactly one game. So if he wins the first game, he could draw the second, or win the first one and lose the second. If he draws the first one, he could win the second. And if he loses the first game, he could win the second. So those 4, 1, 2, 3, 4 outcomes are what we're looking for. So the probability he wins then draws is 0.5 times 0.3. And that is 0.15. The probability he wins and then loses is 0.5 times 0.2, and that's 0.1. The probability he draws then wins, 0.3 times 0.5. We've already worked that out. That's 0.15. And 0.2 times 0.5 for lose then win. Again, we've already worked that out. Just a note on multiplying these decimals. So if you're not sure what the answer is, you can get rid of the decimals and say it's 2 times 5. 2 5s are 10. And the number of decimal places in the question, so you've got 1, 2 numbers after the decimal point. 1, 2. There must be 2 numbers after the decimal point in the answer. So 0.10 or just 0.1. So they're all the options we want. We just need to add those up now for the total probability. So we multiply across the branches and we add when we go down. So it's 0.15 plus 0.1 plus 0.15 plus 0.1. Well, 0.15 and 0.1 make 0.25 plus 0.15, 0.4 plus 0.1. That's 0.5. The probability is 0.5. Question 13. So the cumulative frequency table shows the height in centimeters of some tomato plants. So we've got a cumulative frequency table here. On the grid, plot a cumulative frequency graph for this information. So we've already got the cumulative frequency. We don't have to work it out. Our boxes are 140 to 150, 140 to 160. So it's cumulative. They're adding on as they go. So when we plot a cumulative frequency graph, we're plotting the top point, so 150, against the cumulative frequency. So 150 against 7. 160, 17. 170, 32. 180 against 51. 190 against 57. And 260. So then we just join these up with a curve. So we've got to draw a curved line to join up these points. And then part B says find an estimate for the interquartile range. So there are 60 tomato plants. So the lower quartile is 1/4, which is at 15. So we go from 15 across to our diagram and down. And 3/4 of 60 is at 45. So we go along and down again. So then we can read off these two numbers. So the lower quartile, we've got 159. And our upper quartile, I've got 177. So for our interquartile range, we want the upper quartile, take away the lower quartile, and 77 take away 59 is 18. So 18 centimeters. There'll be a range of acceptable answers for this. So depending on your curve, you might get a slightly different answer, but there will be a range of answers that are acceptable. Question 14. Find the value of 64 over 125 to the power of -2/3. So we've got -2/3 as the power. The thirds mean cube root. So the power of a half is a square root. The power of a third is a cube root. The 2 on top means we've got to square it. And the negative means we've got to flip it over, do the reciprocal. So either the first step we flip our cube root. We don't want to square it first because squaring these numbers will be very difficult. So if we flip it first, so 125 over 64. So now we've got rid of the negative to the power of 2/3. Next step, cube root. So the cube root of 125 is 5. The cube root of 64 is 4. So we've got 5 over 4 squared. And now we can just square it. So times the top times the bottom. 5 squared is 25. 4 squared is 16. Question 15. Write 0.16 recurring as a fraction in its simplest form. So we've got 0.166666666 going on forever. We can call that x. So when we want to get rid of this recurring decimal, we need two things that end in the 6666666 going on forever. So if we multiply this by 10, we get 1.6 recurring. That's 10x. Then if we multiply that by 10 again, we'll have 16.6 recurring, and that's 100x. So now we've got two things that end in the 6 recurring. We can take them away from each other. So I'm going to do the bottom one, take away the top one. 100x, take away 10x. 100 take away 10 is 90, so we've got 90x. And we've got 16.6 recurring, take away 1.6 recurring. So the 6 recurrings are going to go. So it's 16 take away 1, which is 15. So 15 equals 90x. To get x by itself, divide both sides by 90. So 15 over 90 is x. Now these are both in the 15 times table. So 15 is 1 15. 90 is 6 15s. So in its simplest form, our fraction is 1/6. Question 16. ABC is an isosceles triangle. Angle ACB equals angle ABC. So these two angles are equal. So the angles at the base of an isosceles triangle are equal. And these two sides must be equal as well. So this side is also x. The area of the triangle is 60 centimeters squared. Calculate the perimeter of the triangle. So the area of a triangle, we can say is half times the base times the height. Half times base times height. And that's the perpendicular height. That's the height from the top to the bottom. So perpendicular to the base. So straight up from the base. So the area half base times height is 60. So we know the base, and we can use this to work out the height. And then once we know the height, we can use that. We'll have Pythagoras to find x. So area 60 is equal to half times the base, which is 10, times the height, which we're working out. Half of 10 is 5. So divide both sides by 5. 60 over 5 is 12. So the height is 12 centimeters. Now we can work out x. So we've got a right angle triangle. So we've got 12 as the height. So if we're cutting this in half, so just this bit here, half of the base is 5, and this is x. So we can use Pythagoras to find x. Pythagoras, it's in the formula sheet we're given, but it's a squared plus b squared equals c squared. So 5 squared plus 12 squared equals x squared. 5 squared is 25. 12 squared is 144. 25 and 144 make 169. So our x is the square root of 169, and that's 13. So x is 13. So the perimeter, we've got two 13s and a 10. 26 and 10 is 36. So 36 centimeters. Question 17. Here are the equations of 5 straight lines. Write down the letter of the line parallel to y equals x plus 6. So if lines are parallel, that means they've got the same gradient. And the equation of a line is y equals mx plus c, where m is the gradient. So this line has got a gradient of 1. It's just y equals x plus 6. Its gradient is 1. So we're looking for another line with a gradient of 1. And r has a gradient of 1. Y equals x plus 5. They've both got a gradient of 1, so they are parallel. Part B, write down the letter of the line that's perpendicular to y equals 2x plus 1. So 2x plus 1 has got a gradient of 2. A perpendicular gradient is the negative reciprocal, flip a minus. So the perpendicular gradient will be flipped 1/2, a minus minus a half. So the perpendicular gradient is minus a half. So which line has got a gradient of minus a half? That's S. Y equals minus a half x plus 6. Question 18. The diagram shows a cuboid. All the measurements are in centimeters. The total surface area of the cuboid is 172 centimeters squared. Find the value of x. So we've got all the lengths given to us as algebra, as expressions, and we need to write an equation for the surface area. So the total surface area was the area of all the surfaces added together. So we've got the front and the back, which are the same. So we've got 2 of 2x plus 3 times x plus 2. We've got the top and the bottom, which are the same again. So we've got 2 of 2x plus 3 times 2x minus 1. And the two sides are the same. So we've got 2 of 2x minus 1 times x plus 2. So that's the total surface area, and it equals 172. So if we expand all of these brackets and simplify, we'll have a quadratic that we can solve. So I'm going to leave the 2 on the outside and expand inside the brackets. So 2x times x is 2x squared. 2x times 2 is 4x. 3 times x is 3x. And 3 2s are 6. Again, leaving the 2 on the outside, expanding inside the brackets. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 3 2x's are 6x. And 3 times negative 1 is negative 3. And the last one, so 2x times x, 2x squared. 2x times 2 is 4x. Negative 1 times x is negative x. And negative 1 times 2 is negative 2. Before I expand the brackets to get rid of all these 2's, I'm going to simplify inside the bracket, so collect the like terms. So we've got in the first one 2x squared plus 4x and 3x, which makes 7x plus 6. In the second one we've got 4x squared minus 2x plus 6x. Negative 2 plus 6 is 4 minus 3. 4x minus 3. Then in the last one, again we've got 2x squared. We've got 4x take away x, which is 3x minus 2 equals 172. So now we can expand all of these brackets. So we're multiplying everything inside the brackets by 2. So we have 4x squared plus 14x plus 12 plus 8x squared plus 8x minus 6 plus 4x squared plus 6x minus 4, and that's equal to 172. Now collect the like terms, so add up the x squareds, add up the x's, and add up the numbers. So 4x squared plus 8x squared plus another 4x squared will give us 16x squared. 14x and 8x and 6x. 14 and 6 make 20, plus 8 is 28x. And we've got 12, take away 6, take away 4. That's 12, take away 10, which is 2. So we have a quadratic. To solve it, we need to make it equal to 0. So we're going to take 172 away from both sides. So 2 take away 172 will be negative 170. And now we need to factorize this. To make it easier, we can half all of the terms. Half of 170 is 85. Now we need to factorize this. So there's lots of ways of factorizing these quadratics with a number with something other than 1x squared. They all involve multiplying a by c. So 8 times 85. So 2 85s were 170. So double that. 4 85s are 340. Double again. 8 85s are 680. So we're looking for something that multiplies to make 680 and adds to make 14. So we got 10 times 68. If we double the 10, half the 68, 20 times 34. So 20 times 34 multiplies to make 680, adds to make a 14. So 8x squared plus 34x, take away 20x, minus 85 equals 0. So that would have been the line after, if we expand the brackets, we get 4 terms, like here. So with uncollected like terms. And then we can see what would have been in the brackets. So what can I take out of these first 2 terms? So what can I take out of 8x squared and 34x? They've both got a 2x in them. So I can take 2x out of both of them. And then 2x times something makes 8x squared. 2x times 4x makes 8x squared. 2x times something makes 34x. That's 17. And then my next term is something times 4x. So something times 4x is negative 20x. That must be negative 5. And negative 5 times 17 gives me my 85. So what's x equal to? So either this bracket is 0. So either 2x minus 5 equals 0. Or 4x plus 17 equals 0. So x must be plus 5 and divide by 2. 5 over 2. Or x must be take away 17 and divide by 4. Negative 17 over 4. So I can't have this negative 17 over 4. It would make the length a negative, which it can't be. So we reject that one. And the value of x is 5 over 2, or 2.5. Question 19. Write 3 plus root 8 squared in the form a plus b root 2, where a and b are integers. So squared means multiplied by itself. So we've got 3 minus root 8 times 3 minus root 8. And, well, we can either change root 8 now or change it at the end. I don't think it makes a big difference, but root 8 can be simplified. Root 8 is root 4 times root 2. Root 4 is 2, so it's 2 root 2's. I will leave it and change it at the end. You can do it either way. It doesn't matter, you get the same answer. So 3 3's are 9. 3 times negative root 8 is, well, negative. A positive times a negative is a negative. So minus 3 root 8. Negative root 8 times 3, again, minus 3 root 8. And a negative times a negative is a positive. Root 8 times root 8 is 8. So that gives us 9 and 8 makes 17. And we've got minus 3, negative 3, take away another 3, negative 6 root 8. Now we don't want that, we want a plus b root 2. So we need to change root 8 into 2 root 2. So it's 17 minus 6 times 2 root 2. 6 times 2 is 12. So it's 17 minus 12 root 17 minus 12 root 2. Question 20. Given that 2x plus 1, 2, the ratio of 2x plus 1 to x plus 2 is equal to x plus 8 to 3x minus 4, find the possible values of x. So the first thing we can do is to change these ratios into fractions. So 2x plus 1 over x plus 2 equals x plus 8 over 3x minus 4. Now we can get rid of the fractions by multiplying both sides by x plus 2 and multiplying both sides by 3x minus 4. So that will give us 2x plus 1 times 3x minus 4 equals x plus 8 times x plus 2. Then again we're expanding brackets. So 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. 1 3x is 3x. And 1 negative 4 is negative 4. On the other side, x times x is x squared. X times 2 is 2x. 8 times x is 8x. And 8 2s are 16. Collecting like terms. So we've got 6x squared. Negative 8 plus 3 is negative 5. So we've got negative 5x minus 4. And on the right, we've got x squared. We've got 2x plus 8x, which is 10x plus 16. So now we're going to make it equal to 0. So take x squared away from both sides. So 6x squared take away 1x squared is 5x squared. Take away 10x from both sides. Negative 5 take away 10 is negative 15. And take away 16 from both sides. Negative 4 take away 16 is negative 20. Now all of these numbers are in the 5 times table. So let's divide through by 5. So x squared minus 3x minus 4 equals 0. And to solve a quadratic, we're going to factorize. We could always use the quadratic formula, but we haven't got a calculator. So the easiest way is to factorize. So what multiplies to make 4, a negative 4, and adds to make a negative 3, it's 4 and 1. It's going to be negative 4 and plus 1. So x is 4 or x is negative 1. We want the possible values of x, so we want both answers. Question 21. Here is a speed time graph. So that's drawn for us. Work out an estimate for the acceleration when t equals 2. So the acceleration is the gradient of a speed time graph. And because we've got a curve, we can find an estimate for the gradient at this point when t equals 2 by drawing a tangent. So we need to draw a tangent at this point. So that's a line that just touches the graph but doesn't go through it. So draw a tangent. That just touches the graph at t equals 2 but doesn't go through it. So something like this. And now we can work out the gradient of this straight line. So if I can extend it. And find some good points on it to work out the gradient. So I seem to have 0, 4 here. And up here I've got 3, 39. So if I've got 0, 4 and 3, 39, the gradient is the change in the y's, so how much it's gone up by, divided by the change in the x, how far it's gone along. So it's change in y divided by change in x. So the change in the y from 4 to 39 is 39 take away 4. And the change in the x from 0 to 3, 3 take away 0. So that's 35 over 3. And that doesn't simplify. So I'm going to leave that. That's the simplest version. 35 over 3. As with the other questions, where it's an estimate, it's based on your drawing of the tangent. So there will be a range of answers that will be acceptable here. So something in the region of 35/3, which is just under 12. There'll be a range of acceptable answers within that area. Question 22. The table shows pairs of values for x and y. So when x is 2, y is 32. When x is 3, y is 72. Tick the correct statement. So either y is proportional to x, y is proportional to x squared, or y is proportional to x cubed. So if y is proportional to x, y will be equal to k times x. If y is proportional to x squared, it will be k times x squared. And if it's proportional to x cubed, it will be k times x cubed, where k is a number we can work out. So it would have to be the same k value for both sets of values. So when x is 2, y is 32. So 32 is k times 2. So that makes, divide both sides by 2, k would be 16. So does that work for the other one? Y equals 16x. Well, no, it doesn't. So that would be 72 equals 16 times 3. 16 times 3 is 48. It's not 72. So that doesn't work. Y equals kx squared. So 32 is k times 2 squared. 2 squared is 4. Divide both sides by 4. So half of 32 is 16. Half again is 8. So k is 8. So y equals 8x squared. Does that work for the other one? 72 equals 8 times 3 squared. 3 squared is 9. 9 eighths are 72. So yes, that works. So this relationship works. Y is proportional to x squared. So I've already worked out part B here. Write a formula for y in terms of x. The formula is y equals 8x squared. K is 8. So y equals 8x squared. Question 23. BAC is a sector of a circle, center A. AC is 10 centimeters. Find the area of the shaded segment. Give your answer in terms of pi. So we've got a sector of a circle and a triangle here. A sector of a circle and a triangle. So to work out the shaded area, it's the area of the sector, take away the area of the triangle. So area of a sector is the angle we've got, which I write as theta, over 360. So how much of the circle we've got, what fraction of the circle we've got, times the area of a circle, which is pi r squared. So here we've got 60 degrees. So we've got 60 360ths of a circle times pi times the radius squared. Radius is 10, so 10 squared. And, well, I can simplify 60 over 360. So how many 6 is going to 36? That's 6. They're both in the 6 times table. So it's a sixth of the circle. 10 squared is 100. So a sixth times 100 pi, or 100 over 6 pi. And that's centimeters squared. So that's the area of the sector. That's the whole shape. Then we need to take away the area of a triangle. Now, this is the area of a triangle where we know the angle. We don't know the perpendicular height. So the area of the triangle is half AB sine C. That is in our formula page. It's on the formula page. So the area of the triangle is half AB sine C, where C is the angle, so C is 60, and A and B are the two sides next to the angle, and they're both 10, they're both radiuses. So it's half times 10 times 10 sine 60. Half times 10 is 5. Half of 10 is 5. 5 times 10 is 50. So it's 50 sine 60. And sine 60. What is sine 60? So there are different ways of remembering the exact values. One way is with triangles. Another way is to remember something like this. So sine cos square root 0, 30, 45, 60, 90 all over 2, and sine starts at 0 and goes up. Cos starts the other way round and goes down to 0. So sine 60, where sine meets 60, is root 3 over 2. So it's 50 times root 3 over 2. So 50 root 3 over 2, or 25 square root 3. And that is, again, centimeters squared. So the area of the shaded bit is the area of the whole shape. Take away the triangle. So that's 100 over 6 pi. Take away 25 root 3. We'll leave it like this. Actually, I'm going to change that to 50. I'm going to change that to 50 over 3. So we've got a circle, question 24. A circle has the equation x squared plus y squared equals 7. P is the point -2 root 3 on the circle. Work out the equation of the tangent to the circle at P. So let's have a quick sketch. So we've got a circle. So it's x squared plus y squared equals 7. That means the center is at 0, 0, and it's got a radius of, well, square root 7. The point -2, 3 is on the circle. So that's -2, 3. And we want the equation of the tangent. So that's this line. And what I'll draw a radius on as well. So the equation of the tangent at P, which is at -2 square root 3. We can work out the gradient by using the fact that a tangent meets a radius at 90 degrees. So the tangent and the radius are perpendicular lines. So if we work out the gradient of the radius, then we can do the negative reciprocal, flip and minus, to find the gradient of the tangent. So what's the gradient of our radius? So the gradient is the change in y divided by the change in x. So from our point P here to the center, what's the change in the y? So it's gone from root 3 to 0. So we can say it's gone down root 3. Negative root 3. It's gone down by root 3. And the change in the x is gone from -2 to 0. So it's gone up 2. So it's over 2. Negative root 3 over 2. That's the gradient of the tangent. So the perpendicular gradient will be flipped over. So 2 over root 3 and negative. So it was already negative, so it becomes positive. So our perpendicular gradient is 2 over root 3. So the equation of the tangent is y equals mx plus c. The equation of any straight line is y equals mx plus c. Our m is 2 over root 3. And we know it goes through the point negative 2 root 3. So it goes through this point. So we can use these values of x and y to find c. So let's substitute them in. So we've got root 3 for y equals 2 over root 3 times negative 2 plus c. 2 over root 3 times negative 2 is negative 4 over root 3. And to get c by itself, add 4 over root 3 to both sides. So that's c. So we've got the equation of a straight line. Y equals 2 over root 3 x plus root 3 plus 4 over root 3. And that would be a perfectly acceptable answer. We weren't asked to give it in a certain form, so that would be a perfectly acceptable answer. But it could be simplified, so I will go on and simplify this. So we don't usually have, in its simplest form, we wouldn't have a surd as the denominator. We'd do something called rationalizing. So we'll multiply top and bottom by root 3. So we'll have 2 root 3 on top. Root 3 times root 3 is 3. And again, the same over here. So multiply top and bottom by root 3. 4 root 3 over 3. And we've rationalized the denominator. That is probably... We could also add these two together. We may as well do that. So at the moment, we've got root 3 over 1. If we multiply top and bottom by 3 and make the denominators the same, so we've got 3 root 3 over 3 plus 4 root 3 over 3. 3 of something and 4 of something makes 7 of something. So we've got 2 root 3 over 3 x plus 7 root 3 over 3. And that would be the simplest form. But, as I said, we weren't asked to give it in the simplest form. So this here is a perfectly acceptable answer. I'll write the simplified one on the answer line. And there's our answer. Question 25. So we've got a vectors question. We're told O to A is called 2A. O to B, the whole of O to B, is called 2B. N is the point on O to B, such that O to N is 2 parts, and N to B is 1 part. So there's 3 parts in total. So we've got 2/3 of the journey and 1/3 of the journey. So we've got 2/3 of 2B, 2/3 of 2B, and 1/3 of 2B. M is the midpoint of AB, so M is halfway down AB. P is the point on OM, such that APN is a straight line. And we need to find the ratio of O to P to M. Okay, so we need to go from... We need 2 ways of getting from O to P. we can say it's part of the journey of O to M. So O to P is on O to M. And we can also get from O to P by going up to A and then doing part of the journey of A to N. So let's work out this O to M and A to N first. So we're working out these two straight lines. We're working out what they are in terms of A and B. So we'll start with doing A to B. So from A to B, we can go backwards along the 2A, so negative 2A, and then plus 2B. So that's A to B. So A to M is going to be, well, half of that. A to M is the half of A to B. So A to M is minus A plus B. It's half of A to B. So O to M is going to be 2A plus A to M. So O to M will be 2A to get to A, and then A to M, which was minus A plus B, which is just, well, 2A take away A is A, so A plus B. So now we've got O to M. Let's work out A to N as well. So A to N is backwards along the 2A, so minus 2A, and then up to here, which is 2/3 of 2B. So 2/3 of 2B. We can simplify that. So 2/3 of 2B is, well, 2 times 2 is 4, so 4/3 of B. So now I've got these two straight lines. I've got O to M and A to N. So now I can say how to get from O to P. And I'm not going to be able to say exactly how far it is. So I'm going to call the fraction of O to M I've got to travel, I'm just going to call that X. So some fraction of O to M, I'll call it X. So O to P is a fraction of O to M. I don't know what fraction, so it's X of A plus B. O to P is also O to A and then a fraction of A to N. So O to P is also up to A, which is 2A, plus another fraction, I'll call it Y this time, of A to N, which is minus 2A plus 4/3 B. So I've got two ways of getting from O to P. They are both the journey O to P, so they must be equal. So I can say that this and this must be the same because it's the same journey. So X times A plus B equals 2A plus Y times negative 2A plus 4/3 B. So they're equal. I'm going to try and simplify both sides a little bit because I want to separate the A's and B's. So I've got on the left, I've got XA plus XB. On the right, I've got 2A. It's going to be negative. So 2A, and I've got Y times negative 2A, which is negative 2YA. I'm writing the A at the end because I want everything in terms of A and B. So it's negative 2Y times A. And I've got Y times 4/3 B, 4/3 YB. So one more line here. I'm just going to write XA plus XB. And I'm factorizing out the A from these two. So it's 2 minus 2YA and then 4/3 YB. So I've got A's and I've got B's. Because these two are equal, that means the A's must equal the A's and the B's must equal the B's. So this and this must be the same, and this must be the same. The A's equal the A's and the B's equal the B's. So what are my A's? I've got x equals 2 minus 2y, and for the B's, x equals 4/3 y. I want to know what x is, so I really want to get rid of the y, eliminate the y. So from this one, if I multiply both sides by 3, 3x equals 4y, and then divide by 4, I get, well, 3x over 4 is y. And then I'm going to use this to substitute in to my other equation. That will get rid of the y. So that gives me x equals 2 minus 2 times 3x over 4. X equals 2 minus 2 times 3x is 6x. So 6x over 4, which I can simplify to 3 over 2. Then add 3 over 2x to both sides. So that's 1.5x. Adding 1.5x onto x will give me 2.5x's. I'm going to write it as a fraction, so 5 over 2x equals 2, so 2.5x's equal 2. Multiply both sides by 2 and divide both sides by 5. X is 4/5. So what's that told us? This is 4/5. This journey is 4/5. This journey is 1/5. So what's the ratio? I want the ratio O to P to P to M. It's 4/5 to 1/5. So 4/5 to 1/5, or simplified, 4 to 1.